Assalamualaikum, my name is Nur Alia Marina Zinodin and today I will present my thesis entitled Metabolomic Study of Staphylococcus aureus, challenge with metronidazole using gas chromatography-mass spectrometry, and this thesis and project is supervised by Dr. Muhammad Izwan bin Muhammad Yusuf. The goal of the study is that Staphylococcus aureus is a facultative anaerobe that has been widely spread all around the world and has evolved and acquired antibiotic resistance. Antibiotic is a modern drug that is used to treat bacterial infection. Metronidazole, for example, is an antibiotic that belongs to imidazole antibiotic class and is widely used to treat gram-positive bacterial infection. Antibiotic resistance has led to the metabolomic and also biomolecular studies to overcome the antibiotic resistance in the Staphylococcus aureus. This is because metabolomic study allow us to detect and identify any perturbated or any alteration in the small molecule compound up to as small as 1500 Dalton. The problem statement of this study is that the prevalence of antibiotic resistance have been widely spread all around the world, and it is considered as one of the global threats according to the World Health Organization. However, the mechanism of action of antibiotic resistance is not fully understood. Hence, the study focused to investigate the perturbated metabolism in the Staphylococcus aureus in response to the metronidazole at the molecular level. This study will be very important so that we can understand on how the Staphylococcus aureus respond to metronidazole at the molecular level. This could be a contribution to the development of a new approaches or a new antibiotic to mitigate the infection management. The objective of this study is to characterize and identify Staphylococcus aureus by using gram staining technique and by conducting biochemical tests. It is also focused to calculate the colony forming unit of the Staphylococcus aureus at different growth phases, and we aim to profile and identify endogenous metabolite detected in the Staphylococcus aureus in response to the metronidazole. Metronidazole is an antibiotic that belongs to the 5-nitroimidazole class of antibiotic and is very effective in treating protozoa infection. Mechanism of action involves DNA disruption. First, it will enter the cell and disrupt the cell DNA by forming a short nitroso free radical ion, and this will help to modulate the drug intracellular transport. The reduced form of metronidazole and the free radical will bind and interact with the DNA. They will inhibit the cell's DNA synthesis and also will promote the cell DNA degradation that will lead to the cell death. In this study, we use gas chromatography-mass spectrometry because it has a very high sensitivity and also it is very convenient to use. These are the methods that I used to achieve the first and second objective of this study. These are the methods that I use in this study, and this is the GCMS condition that I set to run the sample in the GCMS. For the grams, we were able to identify the Staphylococcus aureus as a gram-positive bacteria, as it has stain in purple and also it has a spherical shape that is arranged in clusters. And for the catalyst test, it is found that Staphylococcus aureus is a catalyst-positive staphylococci. This is because it produces bubbles when the Staphylococcus aureus is inoculated to the hydrogen peroxide. The bubble formation is due to the breakdown of hydrogen peroxide into oxygen and water. This is the growth curve of the Staphylococcus aureus, and we can see that during the first 3 hours, there are no visible changes in the optical density reading at 600 nanometers. And starting from the 4th hours after the inoculation, the bacterial cell started to show an exponential growth. This is because the Staphylococcus aureus is actually in their lag phase during the first 3 hours, and they are actively adapting to their new environment. After the 4th hours, they are actually actively reproducing and also actively synthesizing metabolite. The minimum inhibition concentration of metronidazole against the Staphylococcus aureus is at 17 mg per ml, and the optical density reading was 0.489, while the cell numbers calculated was 3.912 times 10 to the power of 8. This concentration was chosen because our aim is to understand about the metabolite profile of Staphylococcus aureus in response to metronidazole. This is the principal component analysis PCA of this study, where we can see that all the groups were clustered together and about 77.2% of metabolite that are present in the control were also present in the sample. And there is a high correlation between these two groups, so there is no clear distinct separation between the groups. And here we have partial least square discriminant analysis, PLSDA, where it shows a better separation between the groups, but about 77.1% of the metabolite are present in both treated and also untreated sample. The difference between the PCA and the PLSDA is that PLSDA is a supervised data where it has a certain algorithm that allows it to detect and separate each group. The metabolomic pathway analysis has successfully detected and identified perturbation in the glycerol phospholipid metabolism. Ethanolamine is a byproduct from this metabolism pathway, has been reported and found to be upregulated in the treated sample, and this indicates its important role in this pathway. Ethanolamine is very significant as the p-value obtained was 0.026571, and its presence in the membrane is very important because it has a high affinity binding to various antimicrobial peptides. The recommendation of this study is that we require a further analysis that should be done by using different analytical instruments such as liquid chromatography, mass spectrometry, and nuclear magnetic resonance so that we can further justify the finding. It can be concluded that Staphylococcus aureus is a gram-positive bacteria when we do gram staining technique as it is stained in purple. We can also see that it is arranged in cluster and have a spherical shaped cell. It is also a catalyst test positive Staphylococcus. The log phase of the Staphylococcus aureus is within 4 to 7 hours after the inoculation. 37 metabolites were identified in this study, with about 77.1% of them are detected in both control and also treated sample. The detected perturbated pathway is detected by using metabolomic pathway analysis is glycerophospholipid pathway. Ethanolamine, a byproduct of this pathway, is found significant in this study with a p-value of 0.026571. This is the reference that I used in this study. This is the Gantt chart for my thesis.